Imagine a planet with corners and edges, a square world floating in space. The idea seems straight out of a science fiction book, but scientists, physicists, and cosmologists have already wondered whether celestial bodies could adopt such unusual shapes. What would it take for a planet to maintain such an extreme geometry without collapsing in on itself? The reality, however, is that the spherical shape of planets is not just a matter of appearance. It naturally arises from gravity, which distributes mass evenly, from the balance between internal and external forces, and from the fundamental laws of physics that govern the cosmos. Any attempt to create a square world would face colossal challenges, from structural instabilities to drastic changes in gravity and atmosphere, making the idea fascinating but practically impossible. Stay until the end, because I'm going to reveal a secret that few people know about: what would really happen if a square planet existed. Before imagining a square planet, it is essential to understand the force that shapes all celestial bodies: gravity. Any planet forms from dust, rocks, and gas collapsing under its own gravity. In spherical planets, each particle of matter is equally attracted toward the center, creating a curved, uniform surface. This process is gradual, occurring over millions of years, and is responsible for the natural spherical shape of stars, planets, and even moons. To preserve a square shape, it would take a completely different balance of forces than the one we know, something capable of counteracting the natural tendency toward roundness and keeping corners stable without collapsing under their own gravity. But it's not just about materials. The formation of a square planet would have to be carefully orchestrated on a cosmic scale. The mass of a spherical planet distributes weight evenly, allowing stable orbits and a consistent gravitational surface. A square planet, on the other hand, would have extremely irregular gravitational fields. At the corners, gravity would be much stronger than on the flat faces, and any natural satellite or orbital ring would suffer immediate instabilities. Even dust particles in orbit would be unevenly attracted, creating gravitational chaos that could last billions of years. Additional forces, possibly magnetic fields or artificial gravitational systems, would be needed to preserve the integrity of the structure. And what would the surface of a square planet be like? Imagine walking from a flat face toward a corner. Gravity would change in intensity gradually across the middle of the face, but would increase dramatically as you approach the corner, as if you were being pulled in two directions at once. And what would the surface of a square planet be like? Imagine walking from a flat face toward a corner. Gravity would change in intensity gradually across the middle of the face, but would increase dramatically as you approach the corner, as if you were being pulled in two directions at once. Moreover, the planet's internal energy would represent another colossal challenge. The core of any planet generates heat through radioactive decay and gravitational fusion. In spherical planets, that heat is distributed evenly, allowing the crust and mantle to maintain relatively balanced temperatures. In a square planet, however, the corners would concentrate energy, creating regions of partial melting or instability. This would mean that areas near the corners could literally melt or experience unexpected magma eruptions, while the faces might remain relatively cold. Such extreme contrast would require stability systems that are still purely theoretical, possibly involving external forces or advanced technology capable of redistributing internal energy. And what about the atmosphere? A square planet would face extreme challenges in retaining gases around it. Uneven gravity would make the air denser at the corners and thinner across the faces, creating chaotic climates. Permanent winds could sweep continuously across the planet's faces. Cyclonic storms might form at the corners and last for centuries, and irregular cloud layers could block sunlight in some regions while leaving others brightly lit. To make the planet habitable, it would be necessary to create artificial atmospheric circulation systems, possibly giant planetary fans, or magnetic fields that maintain balanced pressure between corners and faces, something far beyond our current engineering. And how would a square planet maintain its orbit? Gravitational irregularities would make any motion around a star unstable. A minimal deviation could eject the planet from its system or cause it to collide with another celestial body. To remain stable, its orbit would have to be constantly monitored and adjusted, perhaps through massive satellites generating gravitational corrections, or even by advanced civilizations capable of manipulating gravitational fields on a planetary scale. The mere act of rotating on its own axis would be a challenge, since the uneven mass distribution would cause unpredictable accelerations and decelerations, affecting climate, tides, and tectonic movement. The corners, in turn, would be the greatest points of tension. Each corner would concentrate extreme force, capable of crushing any matter nearby. The planet's very stability would depend on its structural resistance at those critical points. Any asteroid or cosmic fragment impact could shatter a corner, releasing rocks and gases into space and threatening the world's overall integrity. For a square planet to survive billions of years, each corner would need to be reinforced with exotic materials or advanced alien technologies capable of withstanding unimaginable pressures. The magnetic field would also pose a critical challenge. Planets generate magnetospheres to protect their surfaces from stellar radiation, but the irregular mass of a square planet would make it nearly impossible to generate a stable magnetic field. This could expose its surfaces to lethal levels of radiation, especially at the corners, making any attempt at complex life unsustainable without protection. For habitability, shielding technology would be essential, perhaps through artificial rings of charged particles or magnetic shields redistributing radiation evenly. The internal gravity, in turn, would be completely irregular. Structures, oceans, and even any form of life would have to adapt to abrupt changes in gravitational force. Hypothetical creatures living on that planet would need bones, muscles, and circulatory systems adapted to variable forces, different on each corner and each face. Evolution, in that world, would be radically different from anything we know, potentially creating life forms that float or cling to surfaces, migrating intelligently between regions of lower and higher gravity. Natural erosion would be a constant enemy. Winds, rain, lava, and meteor impacts would tend to round off the corners over time, transforming the planet into something closer to a sphere. To preserve its cubic geometry, continuous intervention would be necessary. Artificial magnetic fields to reinforce the corners, planet-scale geotechnics, active terraforming, and perhaps manipulation of the planet's rotation or gravity. Each corner would need to be constantly monitored and adjusted to prevent structural collapses or deformations, turning the square planet more into an engineering project than a natural phenomenon. Here, a fascinating comparison is worth mentioning. Some flat Earth theories can help us imagine the difficulty of maintaining alternative shapes for celestial bodies. The flat Earth hypothesis proposes that our planet is a disk and not a sphere, arguing that gravity does not act uniformly and that natural phenomena must be reinterpreted. Although modern science has already refuted this idea based on satellite observations, gravity, eclipses, and space images, it gives us a starting point to think. If it is impossible to maintain a stable disk without deformation, keeping a cube is even more complex. Gravity would act in a completely irregular way, and even alternative theories like flat Earth face enormous criticism when it comes to three-dimensional rotating celestial bodies. Theoretical physics offers fascinating paths. Some physicists suggest that in universes with slightly different physical constants, gravity could behave unevenly, balancing each face and each corner of a cubic planet. In those alternative realities, the formation of a square planet could be natural, and the laws we consider immutable would be just one of many possibilities in the cosmos. These ideas explore concepts of multiple dimensions, exotic particles, and interactions not yet observed, opening doors to worlds that completely defy our intuition about the shape and structure of planets. The secret that few know, the true challenge of a square planet, lies not only in maintaining its shape or stability. The real secret is in balancing forces, energy, gravity, heat, atmosphere, and magnetosphere, perhaps even manipulating the very structure of space-time. Futuristic civilizations with sufficient technology could build, monitor, and inhabit a cubic world. Imagine explorers of the future walking from one face to another, crossing corners where gravity increases abruptly, navigating rivers that spill toward the planet's edges, flying through perpetual storms, and studying life forms that evolve to withstand radical gravitational forces. Science, physics, and engineering would have to unite in unprecedented ways, transforming a concept once considered impossible into reality. Each step would be a test of resilience and adaptation, each experience a living lesson about the extreme forces of the universe. And do you think the existence of a square planet would be possible? What other planetary shapes do you think could exist in the universe besides the square and the spherical?